Alright, boys and girls, it's time to get super hyped today because today we are doing an early morning, fun-filled, action-packed, flipped geometry video. Today it is 6:45 a.m. because I forgot to bring my computer home last night, so I'm doing it before class today so everyone can do this if they want to do it. But anyways, today we're moving on from Unit 1 to Unit 2. Get hyped! Today we're moving on to segment length and deriving the distance formula. All right, so let's get started with these notorinos. Okay, so first, how do you find the length of a segment? Look from here, from 2 to 7. What's the distance between 2 to 7? Well, how would you write that mathematically? You know, look, you can just do this. Look, 1, 2, 3, 4, 5. But what would you do? How would you write that mathematically? How do you find 5? Some of you guys may remember all you have to do is subtract the smaller number from the bigger one. So 7 minus 2 equals 5. We got 0.7 right here, 0.2 right here. We subtract one from the other, and then we get 5, and that's our distance. The distance between the two is 5. It's a positive number because we're talking about distance. You don't tell somebody, hey, go walk -5 miles. That doesn't really make any sense, all right? So let's go on to the next part of the notes right here. Let me make sure I'm recording. Okay, there we go. Okay, so the next one. But what if you need to find the length of a segment from a coordinate plane or from a word problem? All you need to do is find the distance from one endpoint to the other. So for example, right here, look at this coordinate plane. That's this grid right there. That's what we call in math, coordinate plane. Remember that? Find AB. How am I going to find AB, the distance between A and B, if A is 2, 3, and B is 4, -1? This picture doesn't even match these coordinates, but you know what? It's okay. I don't know why it's like that. Anyways, let's move on to right here. The something theorem could help you find the distance. Remember, a squared plus b squared equals c squared. What is this theorem called? Does anybody remember? Think about it. Take a second to think about it. If you said Pythagorean, then you would be right. I don't have two hands because I'm holding my computer in my other hand, but that's like a high five for today. Let's go. The Pythagorean theorem. The Pythagorean theorem can help us find the distance. Okay, so if we go down here, let's just look at this. This looks all really confusing right here, but the distance formula is written right here. Distance equals the square root of, in parentheses, x2 minus x1 all squared plus y2 minus y1 all squared. We say quantity squared in math terms. If you want to sound really mathematical, you want to sound like a mathematician, we're going to say quantity squared. That means everything inside the parentheses gets squared. Okay, and if you want to know another math thing, if you want to sound really mathematical, you don't say x little 2 or x2. You say x sub 2 because it's sub, like a submarine. The 2's riding under the water. That is the x. Okay, anyways. So, you know, you might be looking at this distance formula. Like, how did you even get that distance formula? See, using this distance formula, we could find the distance between A and B because look, x2, you know, it doesn't matter which one's 1 or 2, but look, we can choose 1 as x1, that's 1 x2, and then remember the y values are the second number, and we could just go y1, y2. We could just plug these numbers into this distance formula, and after we did all the math, then that would be our distance. So, bonus! How do we even get the distance formula? Where did this formula even come from? Well, remember in the notes right above it said that, how do I get out of the screen? It said that the Pythagorean theorem could help us find the distance. Now let's take a look at this. This is a little bonus right here, but this is going to help. This is deriving the distance formula. So let me draw a little coordinate plane, and then I hope this is, All right, so there's our coordinate plane, right? So let's just put 2 points. Let's put, A is 2, 3 over here. Actually, it doesn't really matter. You don't really know what it is. A and B. Okay, so here's our coordinate plane, right? And now we're going to show you the magic that is math. So it's not really magic, it's just math. But anyways, so look at this. We got 2 points right here. We don't know what the numbers are. Let's just pretend we don't know what the numbers are. And in fact, we don't, because look, I didn't label my coordinate plane. So you have no idea what the actual points are. So let's just call this one x1, x sub 1, comma, y sub 2. Y sub 1, because that's going to be our first point, so we use the ones. And then B over here, we're going to label the point as x sub 2, comma, y sub 2, because that's our second point. Okay, you see that? You see that? Now, look at this. From here, you might be like, wait, how am I going to find the distance? But check this out, though. What if I drew a straight line out here like this, boom, and then straight down 90 degrees? Whoa, look at that right angle. And then what if I did a little bit whoa, what do I have here now? What is that? Does that look familiar, guys? What is that? That's a right triangle. And remember that little theorem that we have that we can use for right triangles? What is that called again? The Pythagorean theorem. If you said Pythagorean theorem, then you'd be right. Remember, the Pythagorean theorem says that, okay, this side's A, B, and C. That's A squared plus B squared equals C squared. And now watch this. How do we find the actual distance between a point? Remember, for the segment, we just subtract one from the other. How would I find the distance from this x value of B, the distance between the x value of A and B? How would I find this distance right here? Well, remember, x is the horizontal distance. So I would just subtract x1 from x2. This is the distance. Remember, on the line segment, we had 7 over here and 2 over here. We just went 7 minus 2, and that gave us the distance. So right here, we're going to take x2, because that's our second point, and subtract x1, or x sub 1. That's going to be our distance right here. And then what do you think our equation would be for the distance in the vertical direction right here? It would be y sub 2 minus y sub 1. Just like that. So that's our two lengths. That's our two lengths. And look how we labeled the right triangle. A is this horizontal distance right here, this horizontal length, and B is the vertical length. So if we substitute and plug in the values that we just found into our Pythagorean theorem, A, what is that one? It is x squared minus, I say x sub 1 minus x sub, I'm losing it, x sub 2 minus x sub 1 squared, because look, there's a squared right here, plus, what was B? B is right here, and that is y sub 2 minus y sub 1, quantity squared. And all of that equals c squared, right? But we're trying to find c, remember? Because look right here. Look where I'm about to start right here. C is the length of this hypotenuse right here. And c is the distance between A and B, isn't it? Look at that. I just drew a straight line from A to B. That is c, which is the length of the hypotenuse, which is also the distance between A and B. And that's what we wanted to find in the first place. So we don't want c squared. So if I wanted to get rid of this little squared over here, how do I get rid of it? I take the square root, right? I put it under a little house thing. So what if I do it like this? Under the house. But if I do that to the right side, I got to do it to which side? The left side. So I got to put it on the left side right here. And then I got to put all these little kiddos under the house. You know what I'm saying? All the kids go under the house. They're like, oh, Mom, I want to be in the house too. So you put everybody under the house. Just like that. And then what happens? What happens when you have a squared right over here and you put it under a house? It cancels, so you would just have your leftover equation would be x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared equals, look, this cancels out, so you just have c. And c was our distance between A to B. And what do you know? Look at this equation and look at our distance formula. Look at our distance formula back over here. It's the same thing. Oh my goodness, except instead of c, we wrote distance. Wow. So as you can see, by taking two points with unknown locations on the coordinate plane and plugging those variables into the Pythagorean theorem, we come out with the distance formula itself. Isn't that crazy? All right, so that is how you derive the distance formula. All right, and now let's do an example. So what was our distance formula again? Let's look at the question. Find AB if A is 2, 3 and B is 4, -1. Leave your answer in radical form. Leave it in radical form, dude. So just let's work this one out together. Watch this. D equals, I'm going to zoom it in so I have some little more space. D equals, remember that's distance. And what was our formula? It's the square root of, let's label our values. I'm going to call this x sub 1 and a y sub 1 because that's our first point. And then B will be our second point, so I'll label this one x sub 2, and this y value over here, y sub 2. So now remember our formula was, x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared, and then all we got to do from here is plug and play, guys. So here we go. D, it equals, let's go. What was x sub 2? Well, we labeled it right here. It's this 4. 4 minus x sub 1. Where is it? That's that 2 squared plus y sub 2. What's that? -1 minus, where's y sub 1? Right here. 3 squared. And then now we're just going to combine the like terms that are in the parentheses. If ever you're having trouble, remember, what should I do first? Remember PEMDAS. PEMDAS. Parentheses. Exponents. Multiplication. Division. Addition. Subtraction. So first, we're taking care of the things inside the parentheses. So inside the parentheses, we got 4 minus 2. What's 4 minus 2? Is 2 squared. Plus -1 minus 3. What's that? That's -4 squared. So that's what's in the parentheses. And then what's next? We got the e, the exponents. So now 2 squared. What's that? That's 4 plus. What's -4 squared? Or -4 times -4. That's going to be 16. And then under here we're going to have the square root of 20. The square root of 20. And what is the square root of 20? It's also the square root of 4 times the square root of 5. Now 5, it doesn't have a perfect square, but what about 4? Which two numbers multiply by itself to equal 4? That would be 2. So we can just change this square root of 4 into a 2 and then leave the radical 5 over there. And that is our answer. Our distance, D, equals 2 radical 5. And so now you do one right here, and then there's 2 more down here where they gave you a picture instead of just giving you the numbers. Try these 3 problems. get your answer, and check it with your teacher. That's the end of this video, guys, so see you later. Peace.